we're going to look at the substitution rule, in particular for indefinite integrals. So we're going to start with some review of the chain rule. So the chain rule states that f of g of x prime is f prime of g of x times g prime of x. And so the idea for the substitution rule is to go backwards from this. We have something in this form, and we want to find f of g of x. We want to find the integral. And so we're going to do this using substitution. So the actual rule says that if u equal to g of x is continuous, and f is continuous, then we have that the integral of f of g of x, g prime of x, is the same thing as the integral of f of u du. So this may seem a little complicated right now, but doing some examples should help with this. So first we'll give an idea. So the first step is to find a function g of x such that a constant multiple of g prime of x also appears. And then after that, we're going to let u be equal to g of x and du be equal to the derivative. And then we can integrate. So we'll do some examples. First, we have the integral of 6x times 3x squared plus 4. So one of the things we may want to look out for whenever we're looking at substitution is something inside of parentheses like this, something raised to a power. In particular, we are going to let u be equal to 3x squared plus 4. Du would then be the derivative, which is 6x dx. And we can see the derivative in the integral, and that's the important part. So this 6x dx is going to become du, and the part inside of parentheses is just u. So I get u cubed du, which we know is 1 over 4u to the 4th plus c. And then the last step is to substitute back in terms of x. U is 3x squared plus 4 to the 4th plus c. Another example, 5e to the 5x dx. So this one may be a little bit more complicated to see the u substitution at the very beginning. However, we have to think about what we know the integrals for. We know the integral of e to the x. So we're going to let u be equal to 5x, and then du would be 5 dx. So now this becomes e to the u, and the 5 dx becomes du. So we have the integral is e to the u plus c, which is e to the 5x plus c. And in general, now that we've seen this, we tend to not write out the u substitution for things like this. If we see an integral of e to the power of a number times x, we usually just write 1 over that number, e to the power. So for instance, the integral of e to the 5x would be 1/5 e to the 5x. Since we have this 5 here, it cancels out. Another one, we see an x to the fourth, and we see its derivative, x cubed. So we'll let u be equal to x to the fourth plus 8, which makes du 4x cubed dx. Now you'll notice we don't actually have a 4x cubed in this problem. We only have an x cubed. So at this point we'll divide both sides by 4. So now this x to the fourth plus 8 to the sixth power would be u to the sixth power. And the x cubed dx is 1/4 du. We tend to write the 1/4 out front. Adding 1 to the exponent and dividing gives us 1/28. And then we would have x to the fourth plus 8 to the seventh plus c. Another example, sine to the fourth x times cosine x dx. Well, we want to see something along with its derivative. We know that the derivative of sine is cosine and the derivative of cosine is negative sine. So we have two functions, both of which their derivatives appear. However, we really need to watch this to the fourth. We can't have a du to the fourth power, so we need to let u be equal to sine. This makes du equal to cosine dx. So the sine to the fourth x becomes u to the fourth, and the cosine will become du. This is 1/5 u to the fifth plus c, which is then 1/5 sine to the fifth of x plus c. One more, the integral of tangent x dx. This may not immediately look like a substitution problem because it's not a product. However, we can rewrite tangent. We can rewrite this as tangent is sine x over cosine x. And now we can actually pick a u. And we're going to let u be equal to cosine this time. In particular because we can't have du be on the bottom of a fraction. So du would be negative sine x dx, or negative du is sine x dx. So this is the integral of the sine x dx becomes du, and the cosine x would become 1/u. And we have this negative sign here as well. So the integral of 1/u is ln of u. So we would have negative ln cosine x plus c.